So in this demonstration, we're going to look at network observability now and how we can use the cPacket range of network observability tools, our cVu, cStor, and cClear range of solutions to identify network congestion and server resource issues. So in this demonstration, what we're going to do is look at measuring all of the data points through the network and look at data coming into and out of all of our servers, our load balancers, our clients, endpoints, anywhere in the network. And these monitoring points allow us to look at round trip times and latencies performed or introduced within those servers or those endpoints. So in this particular case, we're looking at two endpoints. We're looking at data coming into the load balancer, which is our pre-balancer monitoring point, and the data that's coming out of our load balancer and into our application server, so our post-load balancer. And by monitoring the transmit and receive with very accurate timestamps that are being added by our packet broker, we're able to look at how long that server takes to process each and every request at full line rate performance. So here we can see our load balancer and our application server. So our load balancer is the red line and our application server is our green line, and we can see how long it takes for each of them to service the requests. And we're in the range of a few hundreds of microseconds up to maybe a millisecond. This would be a typical normal operational characteristics for the network. Now what I'm going to do is I'm going to send a command, and I'm basically going to break the load balancer. So I'm going to change the configuration on the load balancer. Maybe you've done a configuration update, or maybe there's a problem with the network performance that is going to break the load balancer's overall performance. So I can basically, by sending that single command to the load balancer, I'm able to change its characteristic and basically start to introduce errors and increased latency on the processing time within that load balancer. And what that means is that the load balancer's characteristics are going to change, and we'll start to see an increase in latency being measured between the transmission and reception of packets coming into and out of the load balancer. So immediately you can see here that that change has drastically increased the round trip time latency on the load balancer, and we can see now we're introducing 20 milliseconds of additional incremental latency due to resource limitations, constraints, or misconfiguration within that load balancer. So having that immediate feedback, because we're looking at every single packet, every session going into and out of the load balancer, and you can see that it hasn't affected the application server. It's only affected the load balancer. So we can now drill down now and look at that in a lot more high accuracy, and we can see every monitoring point is telling us that there is an increase in latency and performance of the load balancer. Now, because I've got an alert set up, that increased latency and round trip time from that monitoring point will now trigger an event to be pushed to our alerting system. So now I can have the system send an email, or I can have it send me a WhatsApp message or some third-party integration. Now in this particular case, I'm going to have it send a message to our Datadog service. So I can look at my Datadog dashboard when I come in, and I can actually open my service management and my incidents panel, and I can now look at, for example, the last 5 minutes, and you can see at the top we have now a hop-by-hop latency at the load balancer has been detected. So the system has detected that the load balancer has gone out of specification. It's raised a flag. It's not only detected that there is a hop-by-hop problem, but it's identified where in the network that problem is. So here we can see a breakdown of that. The ticket tells us exactly where the problem is in the network. It gives us access to the dashboard. It also gives us information like, for example, the PCAP file, so that we can open up the PCAP. We can look at the requesting client, the app load balancer. We can look at all the transactions, and we can see the timing with our timestamps and understand exactly what's going on, and we can start to break down exactly where the problem is within the system. We can do the same thing with ServiceNow, so we can open up our ServiceNow integration, open our incidents, and again we can see that there is a hop by hop incident has been detected, and we can open that incident just like we can do with Datadog, and we can see that information. Okay, so again, we have all the information, the access to the PCAP, everything that we need to know. We can also automatically assign that to our network admin tool, team to have them investigate further and to fix the problem. So very quickly, we're able to identify and root cause exactly where the fault is in the network, assign it to the right team, and also get direct access to the information needed to fault find and analyze that. And this is only possible with the real-time analytics at full line rate that the cPacket range of network observability tools offers, because of our unique way of accessing and investigating, timestamping and analyzing data at all layers within the OSI stack.